Okay, so I am going to just do a quick review of some of the equations that you need for Unit 1. Remember that Unit 1 is forces in motion, and there are about 4 or 5 different equations that you need to have memorized for this. So the first one is something that's probably familiar to most of you from basic math, is that the idea that the average speed is going to be the distance moved over the time that it takes. Okay, and so if you want to have that in letters, in abbreviations, then remember that speed, we use V for velocity, and the distance is actually S and T. Okay, now the other thing you may want to remember is the units that those are in. So the distance here is always in meters. Okay, and the time is always in, seconds. So that means that the speed or the velocity is going to be in meters per second. All right, so that's your first basic equation. Not new, but please take note of the units. All right, that's your first one. The second one then is acceleration. Okay, and so you have the acceleration is, so acceleration is defined as the change in speed. Okay, and so in order to know the change in speed, then you need to know, of course, the final velocity. Okay, and then you have to subtract the initial velocity. And that is again divided by the time that is taken. All right. And so in letters, then you would have A for acceleration. The final velocity is V, as it is up here. Okay. Initial velocity is U. You can remember that because U comes before V in the alphabet. So this is the first one. This is the second, what you end up with, U and then V. And that is again divided by time. Okay. And the units for this all stay the same. So this is again meters per second. The time is in seconds. And so that means that the acceleration is in meters per second squared. All right, everybody see that? All right, and so the next equation that I want to talk about, it's not one that you need to have memorized. It is given to you on the test, but a lot of students tend to overlook it, and I want to compare it to this equation that we have here, the second equation. So the third equation is, and I'm just going to write this out in symbols because all of the symbols are ones that you will have seen before, okay? So the idea is that it's the final velocity squared equals the initial velocity squared, okay, plus 2 times the acceleration times s. And remember that s is actually the distance that's been moved, all right? So let's make a note of that. So that's going to be the distance. All right, so this one, as I said, is given to you, all right? And students usually don't have problems figuring out if you're given values, then you plug it in and you come up. So for example, you want to find the final velocity, they give you the initial velocity, the time, the acceleration. Very straightforward, okay? But the thing to note about this one that students get confused on is sometimes they don't know which one to use. Are you going to use the second one or the third equation? And the idea for that is that you have to take into account the information that's being provided to you, okay? So these all have an A in it, right? They all have a V in it, and they all have a U in it. So the only difference here between these two equations is actually the time or the distance, which one is being provided to you. And so if you have an exam question where you're talking about the acceleration and the final and initial velocity, that doesn't tell you which equation you need to use until you see whether you are given a time or you are given a distance. If you're given a distance, then you want to use equation number 3. And if you're given a time, then you want to use the second equation, okay? So those are your 3 basic equations. They're called the SUVAT equations, in case you're ever asked. But those are 3 of the basic equations that you need from unit 1. The other two equations that you need from Unit 1 are not part of the SUVAT equation. Instead, they deal with forces, okay? And the basic force equation, okay, which is actually the same thing as Newton's second law. Uh-oh, I've lost my focus here. See if I can get that back. Okay, so this equation actually is Newton's second law of motion. As most of you guys know, there's three, Newton has 3 laws of motion. And so the second one is that the force that something exerts is equal to its mass times the acceleration. Okay, and so, and this is abbreviated F equals M times A. And again, when we're talking about units, okay, mass is always measured in kilograms. Acceleration, we already know, is meters per second squared. And the force is measured in something we call newtons. And that is abbreviated with a capital N, newtons. All right. And so the idea is that there's a couple things that come out of this, okay? Is that the force that something is experiencing, sorry, before I said exerting, I meant experiencing, is equal to its mass times its acceleration. So there's a few things that we know about that. One is that if an object is not accelerating, if it's not changing speed and the acceleration is 0, that means that there is no resultant force, no overall force that is being put that is being experienced by that object, okay? So if something has a constant velocity or is not moving at all, then the forces that are acting on it must be balanced, okay? Now, another form of this equation, which is the idea that the force, okay, so the force is simply how much something is pushing or pulling on another object, right? And so we all exert a force on the earth below us, and that is called our weight. So in physics, weight is not measured in kilograms, okay? Instead, it's a force. It is the force of us pushing down on the earth or any object being pulled to the earth by gravity. And so we call that the weight of an object. So the weight is equal to the mass of the object times what we call g. And g is the acceleration, okay, so it's the same as up here, but it's the acceleration due to gravity here on Earth. And for the iGCSE, this is 10 meters per second squared. The actual value is 9.81, but you guys don't need to know that. In order to make your math easy, they let you use 10, okay? So, and again, the units, note the units are the same as the acceleration, okay? Meters per second squared right there. So mass, again, is still in kilograms, and that means that weight, of course, is going to also be in newtons. All right, so these two equations are actually the same thing, just in different forms, because the g is the acceleration due to gravity here on Earth, and that has a constant value. If they give you questions about other planets, which they have occasionally, Mars or the moon or something like that, they will give you what the g value is, okay? So let me just write up here what this is. This is the it's the gravitational force. It's literally sometimes called the g-force, so it's the gravitational force, the force of gravity on here on Earth. So this is your fourth equation, and this is your fifth equation. So these are the 5 basic equations. Let me see if I can get them both in one shot. There we go. Those are your 5 basic equations that you need for Unit 1, okay? So I'll be giving you some questions to practice these. And just remember that this one, the third one, is actually provided, so you don't need to memorize this one on the exam. It's on the formula sheet there. Okay, so these are your 5 equations for Unit 1. I'll do another video about some of the concepts and ideas in Unit 1, but this should get you a good start.